Okay, Assalamualaikum to all students. Bismillahirrahmanirrahim. So now let's continue on the technique of biasing. So as we know from the previous slide, why we need biasing? So we need to do DC analysis in order to make sure your BJT is in active region. Why you want to make it in active region? Because you want to amplify. So what is the technique to bias? So we have three techniques, but in this semester you only learn about voltage divider biasing. So this is the sample of the circuit for voltage divider biasing. So we have four resistors. One is R1, R2, RC and RE, where here is C, collector, base and ammeter. So this is a very stable bias circuit, means you are going to get a very stable Q point, that is VCE and ICQ. So it is important to have a very stable Q point in order to make sure that the transistor amplify correctly. Okay, so now let's look at the circuit. So we have four resistors, but we have two capacitor connected to AC source. So means this is a small signal of AC. Your transistor will be amplified if the biasing is done correctly. So now when we do biasing, we need to change the position of the capacitor. So since this is DC analysis, so as explained before, your capacitor need to be open. Why? Because if you see the impedance of the capacitor is Z equal 1 over J omega C, omega is 2 pi F, right? So at your DC, you don't have any frequency. Your F will be equal to 0 because it will not depend on time. So the whole here will become 0, 1 over 0, it become infinite. Infinite means your capacitor here will be open. So it will be isolated and will not be connected to any AC sources. Okay, so now in order to solve the voltage divider biasing circuits, so you need to recall back what is actually Thevenin equivalent circuit. Why you need to learn Thevenin? Remember the word simplify. You are given a complex circuit, so you need to simplify the complex circuit into how many elements for Thevenin? So you have two elements. So one here is VTH. So VTH will be in series with RTH. So you will have only two elements, and here you are going to connect to your load. So why we need to do Thevenin at a voltage divider? To simplify the circuit, so it can be only two elements left inside the circuit. Okay, so now this is a voltage divider biasing circuit. So you need to change the circuit into the Thevenin circuits at the base part. So from here until here. Okay, so first of all, this is DC analysis, right? When you do biasing, you are doing DC analysis. Now what will happen to your capacitor? Your capacitor will be open. So now there is no more connection to your input signal and your output signal, and your transistor will become, here is R1, here is R2, here is your BJT, here is your RC, and both of the RC and your R1 is connected to your VCC, and here also VCC, and here is your RE and R2. Okay, and hence all are connected to the ground. Okay, so what you need to do now, since your VCC, the positive is connect to R1 and it also connect to RC, so what you need to do now is to interpret the input voltage here into another simplification of the circuit. So since this one VCC is connected to plus, right? So if I make it like this is plus, right? And then it connect to your VCC, and here is your R1, and here is connected to your BJT at your base. And how about R2? Now your R1 and your R2, here is VCC negative, and here is your R2, and then this connect to the ground. Here you have RE, and the above one you have RC. Okay, So the above one will be connected to your VCC. So what you need to do now, you need to change the Thevenin at the connection at your base. So if I restructure the circuit, so it become here, it become R2, R1 is connected to the other side, and this is connected to your VCC, and then the whole will be ground. So the whole of the circuit here is connecting to your BJT at your base, and here you have RE, and then here you have RC, and then towards your VCC also. Okay, so at this area where you're going to change to Thevenin. Okay, so how are you going to convert this circuit to Thevenin? So the input from the base, this one will be your VTH. So let's say you have, this is your VTH, the open circuit, and here is your R2, here is your R1, and VCC. Now let's say you're going to read your VTH from here. So remember how you're going to find VTH. So using voltage divider, VTH equal R2 divided by R1 plus R2 multiplied by VCC. So this will be equation number 1. Now next, how are you going to find RTH from this circuit? So remember RTH, what you need to do first is you need to turn off the voltage source, right? So in order to turn off this voltage source, it is open or short. So it need to be shorted because this is a voltage source. So what is the value of RTH looking from here? So your RTH will be equal to R2 parallel to R1. So the formula for your VTH is R2 divided by R1 plus R2 multiplied by VCC. Your RTH will be R1 parallel to R2. Okay, hence just now you can get your VTH equation, right? And your RTH equation. So from this original circuit of voltage divider, so you can see here, it will transform to the Thevenin equivalent circuit. So where we will have here VTH and RTH in series, connected to where? Connected to your base of your BJT. So what is the equation for VTH? Equal R2 divided by R1 plus R2 multiplied by VCC. What is the equation for RTH? Equal R1 parallel to R2. Okay.